can you use ratios to convert customary units of measure? Think about this question during the lesson. The sidewalk in front of a store is 4 5/10 feet wide. The city regulations require the width of a sidewalk to be a maximum of 66 inches. Does the sidewalk meet the city regulations? The equations in the table can be written as rates that compare equivalent measurements. Here is one way to solve the problem. Write the width of the sidewalk in inches. First, identify the conversion rate that relates to the measurement. Find an equivalent rate. By what number should you multiply both terms of the original rate to find the unknown value?
Select your answer.
Multiply both terms of the rate by 4 5/10. The sidewalk is 54 inches wide. It meets the city regulations. Here is another way. Use dimensional analysis to convert measures by including measurement units when you multiply by a conversion factor. A conversion factor is a rate that compares equivalent measures. Multiply by the conversion factor that relates the measures. Divide out the common units. Dimensional analysis is a problem-solving method. It uses the fact that when any number or expression is multiplied by 1, its value does not change. What form does 1 take in this problem? In this problem, 1 takes the form 12 inches over 1 foot. The sidewalk is 54 inches wide. It meets the city regulations. Now you know how you can use ratios to convert customary units of measure.
According to city regulations, how many feet wide is the maximum sidewalk width of 66 inches? Explain.
The conversion factor we're going to use is 1 foot is 12 inches, and we're going to multiply the 66 inches to the conversion factor. Now we're going to divide out the inches so that we're left with 66, because the 66 times 1 is 66, and then we're left with 12. And so then you divide 66 and 12, and that would leave us with 5 5/10 feet, because that is the unit of measure we're left with after dividing out the inches. And it says how many feet wide is the maximum sidewalk width? So we have 5 5/10 feet.
Jonah has 15 gallons of water for a camping trip. How many quarts of water does he have?
One way is to use an equivalent rate. 4 quarts is equal to 1 gallon, and that was from the table here that they gave us. And that's our conversion rate we will use. So we have 4 quart over 1 gallon, and you got to multiply that by the 15 gallons of water. So you have multiplying by the 15, and 4 times 15 gives us 60, and then 1 times 15 is 15. And then you have to do look and see that for those 15 gallons, you have the 60 quarts of water. So that's a ratio there. Another way is to use dimensional analysis. So you have the 15 gallons multiplied by the conversion rate, which is 4 quarts to 1 gallon. and then you multiply by that conversion factor. So that's why we're multiplying the 15 times the 4 to 1. And then you divide out the common units. And then you're left with just 15 times 4. And that equals 60 quarts. So Jonah has 60 quarts of water.
Brandon is making bread. His recipe says to use 2 1/2 tablespoons of sugar. How many teaspoons of sugar should he use?
Okay, so we need to find our conversion rate. So we're looking for teaspoons and tablespoons. So in my chart they give us for the customary units, I see there is 1 tablespoon equals 3 teaspoons. So I want to know how many teaspoons. So I'm going to have my 3 teaspoons as the top of my ratio over 1 tablespoon. And I'm going to use multiplying by the 2.5. And I am going to make my fraction that's a half into a decimal. And we know 1/2 is like saying 50 cents. So my decimal for 2.5 will be 2.50 or 2.5. Either way is fine. So I am going to use the dimensional analysis, and I'm going to, and I forgot to add my tablespoons here, and then that's going to cancel out. We're going to divide those out, the units, the tablespoon units, so we're left with teaspoons. And now you're going to multiply the 3 teaspoons times the 2.5, and we get 7.5 teaspoons. So how many teaspoons of sugar should you use? 7.5 teaspoons.
Pica is a small mammal in the rabbit family. How much does the alpine pica weigh in pounds? The scale shows that the pica weighs 10 ounces. The number of ounces in the conversion rate is greater than the number of ounces that the pica weighs. We'll use division to find the equivalent rate. One way to convert ounces to pounds is to use an equivalent rate. Identify the conversion rate from the table. 16 ounces equals 1 pound. The conversion rate is the ratio of 16 ounces to 1 pound. To find the equivalent ratio for 10 ounces, divide both the numerator and denominator by 1 6/10, because 16 divided by 1 6/10 is equal to 10. Now calculate 1 divided by 1 6/10, which is equal to 625 thousandths. In the fraction, the numerator shows the weight in ounces, and the denominator shows the weight in pounds. So, the alpine pica weighs 625 thousandths of a pound. Another way to convert ounces to pounds is to use dimensional analysis. Multiply the weight of the pica in ounces by the conversion factor, which is 1 pound divided by 16 ounces. Notice that the conversion factor is the reciprocal of the fraction that we used to solve the problem earlier. Why is this form of the conversion factor useful? By using this form of the conversion factor, we can divide out the common units. Ounces cancel out of the expression, so the equivalent expression is 10/16 pound, which in decimal form is 625 thousandths of a pound. The alpine pica weighs 625 thousandths of a pound.
How many pounds does the elephant weigh?
To find how many pounds the elephant weighs, we look at our customary units table, and we see that we have pounds to ounces, and we also have tons to pounds. So it says here Stella weighs 3 3/10 pounds. Tons. So we're going to use the conversion factor. 1 ton is equal to 2,000 pounds. So I'm going to use the dimensional analysis where we are multiplying the conversion factor of 1 ton is equal to 2,000 pounds. I want pounds as my unit of measurement in my answer. So I'm going to put 2,000 at the top and the 1 ton at the bottom. And then I'm going to multiply the 3 3/10 tons. So now I'm going to divide out my tons, and I'm left with, I forgot to add that, I'm left with my pounds. And so now I just multiply the 2,000 times the 3 3/10, and we get 6,600 pounds. So Stella would weigh approximately 6,600 pounds.